Okay, so this is chapter 1 point, hold on a sec, let me just back this up a bit. Chapter 1.1 of the book in the comments. So now we're starting algebra for real. And the first thing is called solving linear equations. What is a linear equation? Well, we always look at things with, you may have seen this before, it's the x and y line. So let me just do sort of a graph. All right, like this, like this, like this, like this, and this is 1, 2, 3, and this line here, this whole line here is x, and this vertical line here, or the one that goes from top to bottom, is y. Minus 3. So anytime you go to the left of 0, you're in negatives, and every time you go below 0, you're in negatives. And anytime you go above, you get positive. All right? So what is a linear equation? It's basically this. This is a line. That's a linear equation. 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 That's pretty much what linear equations are. You're gonna, and the way it works is that you're gonna plug an x into the equation and it will give you a y. So, for example, x plus 3 equals y. So if I look at any x here, so for example, if I look at this 3 here, this x3, well, if I plug in that 3 here, 3 plus 3 equals 6. So I know that I will go up 1, 2, 3, 4, 5, 6, because this is 6, right? 4, 5, 6. And I know that if I plug in a 3, it will correspond to 0.6 on the y. And that's what we're dealing with. So, and every number that you plug will give you a line, will give you a point. And then what you're going to do is going to connect the dots and you should get a straight line. That's what a linear equation is. So let's do it more beautiful now, because this certainly isn't beautiful. Let me just get out of here. So what did I do? I typed, you do is you type graphing calculator. I came here, right? And now I got a graphing calculator. So this is the x and this is the y. So here we have a problem. They're showing us a problem here. So we'll type it in right away. 4x plus 16. So this is what this problem looks like. Let's read what they're saying. So it says, solving linear equations is an important fundamental skill in algebra. No kidding, or else they wouldn't be teaching it. In algebra, we are often presented with a problem where the answer is known, but part of the problem is missing. The missing part of the problem is what we seek to find. For example, then they do 4x plus 16 equals minus 4. Now, let's look at what they're saying here. Okie dokie. 4x plus 16 equals minus 4. And really what I was saying before is 4x plus 16 equals y, right? Because this is the x line and this is the y line. If I take any x, I can plug it in here and get where it will appear on a y. So if I put, let's say, I don't know, a 2 here, right? That's 4 times 2 equals 8 plus 16 equals y. So if I put a 2 here at x, it's going to give me, we're going to be 2 to the right of 0, and we're going to be up 24, right? Because 8 plus 16 equals 24, and that would be your y. So that's what we're dealing with. But here they're giving you already the y. They're giving it to you already. They just want to know what the x is. They're doing it in reverse. They're trying to mess with you. So let's look at how they would do that. All right? So in example 41, they give you 4x plus 16 equals minus 4. Let's read what they say. Notice the above problem has a missing part, or an unknown, and this is marked by x. If we're given that the solution to this equation is minus 5, it could be plugged into the equation and replace the x with minus 5, as shown. So wait a minute now. So let's go back to our graphing. This is what our graph looks like. And we know y equals minus 4. And minus 4 is right here. Right here. If I go here, I get minus 5. Boom. That's the x value at minus 4. So I think that x is going to be minus 5. Let's see if I'm right. Now it says, notice the above problem has a missing part or unknown marked by x. If we are given the solution to this equation is minus 5, we could plug it in, replacing the x with minus 5. This is shown in example 2. So basically they gave you the answer to the problem. So let's go back here. So they're saying if this guy here is minus 5, I showed you on the graph that at minus 4y, we get minus 5. Hold on. Let's take a look at this. Let's do the problem. So 4 times minus 5 plus 16 equals negative 4. 4 times negative 5, negative times a positive equals a negative, right? Plus 16 equals minus 4. Negative 20 plus 16 equals minus 4. Yeah, that looks good. That looks good. Plugging in minus 5 got the right answer. And this is the work that they're showing. Notice the equation comes out to a true statement. Now that's pretty complicated stuff. True statement. What he means is the right answer, right? That's what he means by that. It's the right answer. Notice also that if another example, for example 3, were plugged in, we would not get a true statement seen in example 4. Well, there can only be one y for every x, right? Example, that's really complicated stuff, all right? So what they're going to try to do is they're going to try to plug in the number 3 here and see if both sides are equal. I don't know why they're teaching it like that. I mean, it's not really the good way to teach it. Anyways, I'm going to do it their way, and then I'll do it my way after. All right, so what do they want to do here? Okay, so if I do 4x plus 16, 4x equals minus 4. We're starting here. And then they're telling us that, notice that if another number, for example 3, were plugged in, oh, hold on, 3, we would not get a true statement as seen as example 3 because we got minus 4 on both sides. So let's see if by solving for this, we're going to get this. That's what they're saying. So 4 times 3 plus 16. I just added those brackets there to emphasize that we're going to do the multiplication first, equals minus 4. 12 plus 16 equals minus 4. 28 equals minus 4. Well, 28 doesn't equal minus 4, so it's certainly not 3, the solution to this problem. Let's keep on reading what these people say. Due to the fact that this is not a true statement, this demonstrates that 3 is not the solution. However, depending on the complexity of the problem, this guess and check method is not very efficient. Thus, we take a more algebraic approach to solving equations. Algebraic approach means not trying different numbers to get the same solution. Here we will focus on what are called one-step equations, or equations that require only one step to solve. While these equations often seem very fundamental, it's important to master the pattern for solving these problems so we can do more complex problems. That's the common thing in math. You learn one thing, it's easy, but then you add something else over it, you add something else over it, you add something else over it, and you always have to keep in mind what you learned on the first shot. So, addition. To solve equations, the general rule is to do the opposite. For example, consider the following example. Well, let's consider the following example. What are they saying here? X plus 7 equals minus 5. Okie dokie. So when you have this equal sign, it allows you to do a bunch of things. First of all, you can add or subtract, if you add or subtract the same thing on both sides, you will get a valid answer. I know that kind of blew my mind when I was learning it, but it doesn't matter. Because if you think about it, if I have, let's say 5 boxes, two boxes on each side, and then I add a box on each side, well, that's a true statement. 3 boxes equals 3 boxes. Let's say I add half a box here, and I add half a box here. Well, 3.5 boxes equals 3.5 boxes. So let's say I add, I don't know, let's say a coconut. And I add a coconut here. Well, 3.5 boxes plus a coconut equals 3.5 boxes plus a coconut. Let's say I add an airplane here. Then I add a helicopter here. Well, then it wouldn't work out because you're not adding the same thing to both sides. So 3.5 boxes plus a coconut and a helicopter do not equal 3.5 boxes, a coconut, and a plane. So you always have to add or subtract the exact same thing on both sides for it to be right. Okay, so now we know that. Very good. Let's do some examples of that. So for example, if I have 3 here equals 3. 3 equals 3. Do we agree? So let's add 3 on both sides. So 3 plus 3 equals 6. 3 plus 3 equals 6. Do we agree that these things equal the same? Because I added the same thing to both sides. Now let's say I add a square. Add the exact same square to both sides. So now I have 6 plus square equals 6 plus square. And let's say I add an eyeball to each side. That's an eyeball. So each side I'm adding the exact same eyeball. So that would be 6 plus squared plus 1 eyeball equals 6 plus squared plus 1 eyeball. All right. I'll add another thing now. Let's add an x. Oh, plus x. Plus x. Plus x. If I add the same thing to both sides, well, I now get x plus 6. I'm not multiplying x here, I'm just adding. Plus square plus an eyeball equals 6 plus squared plus an eyeball plus x. It's the exact same thing. 6 and 6 are here. Square and square in here. I got an eyeball on each side, and I got an x on each side. Now that equation, all those equations are equal. I want you to pin that to the back of your brain while we're doing this.